Hello everyone. My name is Shrinit Singh and I am a PhD student at Shiv Nadar Institution of Eminence. The title of my talk is Endomorphic Equivalent Words in Free Group. So two words are said to be endomorphic equivalent if two words in a group, two elements in a group G are said to be endomorphic equivalent if there exists endomorphism taking the first word to second word and there exists another endomorphism taking second word to first word. So we will be looking at words via images of corresponding word maps on finite groups. And we will see some partial results, like if given a word, given two words which have same image on every finite group, then those two words will be endomorphic equivalent. We'll see some partial results. So the motivation for the talk is from the conjecture from Shalev and Amit Vishne. So to understand the conjecture, let's set up some definition. So let G be any finite group. So any word W induces a probability measure on the group G, on a group G. So on finite group. So the measure is push forward measure via word map corresponding to W. So now we say that a word W is said to be profinitely rigid if any word W dash inducing same probability measure as W on every finite group is automorphic to W. So the conjecture is that every word in finitely generated free group is profinitely rigid. And Puder and his collaborators proved that powers of primitive words and powers of commutator words are profinitely rigid in any free group, in any finitely generated free group. So now we state a lemma, which is let W1 and W2 are be two words in Fn. Fn is a free group on n generators. So such that W1 and W2 have same image as word map on every group, then W1 and W2 are endomorphic equivalent. In fact, the converse is also easy to prove. Converse is also straightforward, that W1 and W2 are endomorphic equivalent, then they will have same image as word map on every group. Now, the aim of this talk is that two words which have same image as word map on every finite group, then will W1 and W2 be endomorphic equivalent. So we will give partial results on this, and first we will set we'll set a definition of weakly profinitely rigid. An element gamma in a finitely generated free group Fn is said to be weakly profinitely rigid if every element beta in Fn with same image as gamma on every finite group G implies that gamma and beta are endomorphic. And we asked that question whether every word in finitely generated free group Fn of rank and weakly profinitely rigid or not. So certainly it is easy to prove that every word in F1 infinite cyclic group is weakly profinitely rigid. In fact, one just needs to look at the images of any word in F1 inside a finite cyclic group. We'll get the result. And in fact, every word is also profinitely rigid in F1 also. So now, so we'll see we'll prove that x raised to d and xy raised to d are also profinitely, weakly profinitely rigid in F2. So so we'll give some equivalent condition on whether equivalent condition for two words having same image on every finite group. So let G hat denote the profinite completion of a group G, and I be I is a map from G to G hat. I is a standard map from G to G hat. If G is residually finite, then I is an injective map. Uh, so the theorem is that let F be a finitely generated free group. W1 and W2 are two elements in free group. Then IW1 and IW2 are endomorphic equivalent in F hat. Here endomorphic equivalent meaning they continuous endomorphism in F hat. So IW1 and IW2 are endomorphic equivalent in F hat if and only if the image of word map induced by W1 and W2 are same on every finite group. So now the definition of weakly profinitely rigid is that an element W1 in a free group F is said to be weakly profinitely rigid if for any W2 in F, whenever IW1 and IW2 are endomorphic equivalent in F hat, and then W1 and W2 are also endomorphic equivalent in F. So, this lemma was proved by Fude and his collaborators that when given a word W in a free group, such that every image of W on every symmetric group Sm is a dth power for some D in Z, then there exists V in the free group such that W is W equals to V raised to D. And another lemma which he proved that every root of W in Fn hat belongs to Fn. So W is already an element of Fn, and any root in Fn hat will also belong to Fn. So the consequence of these two lemmas are that if W is weakly profinitely rigid in a finitely generated free group, then W raised to D is also weakly profinitely rigid. So this is easy consequence of the above lemma. The first lemma will boil down that W raised to D will be uh, any other word V which have a same image as W raised to D, then there must exist U such that V must be U raised to D, and from the second lemma, the result is we can get the result. And using weak profinite rigidity of the word W. And now, so we define test words. So test words are basically those words if any endomorphism fixing that word uh, will become an automorphism. So Turner has classified test words in general, and so we proved this theorem that for a test word W in a finitely generated free group, and U be any other word in the same free group, such that W and U have same image on every finite group, then W and U will induce same probability measure on every finite group. So so to prove this result, we need to prove that if W is a test word, then W will also remain a test word in its profinite completion. Basically, IW will be test word in Fn. So the next theorem is a test word is weakly profinitely rigid if and only if it is profinitely rigid. Same kind of result. Uh, so now these are the corollaries of previous two slides. So it is easy to prove that, not hard to prove that every surjective word is weakly profinitely rigid. Hence, any powers of surjective word is weakly profinitely rigid. And Puder and his collaborators proved that the powers of commutator words are profinitely rigid, and powers of commutators words are paste words in F2 also. So they are weakly profinitely rigid. The corollary to the previous two slides. And these are the references. And thank you for your attention.